Hi, my name is Johan Hovold, and I'll be giving a status update for the ARM laptop project, which I've been working on now for the past 2 years. It's coming to an end, so it'll be a bit of a lessons learned, status update, a bit of background on the project. I guess people in here have heard about the Windows on ARM marketing term. It's used for laptops built on predominantly Qualcomm ARM SoCs. These devices have some nice properties in there that they are quiet and power efficient, but they also come with some quirks. We have a non-standard boot chain, and they rely on having a fairly heavily customized OS for things like power management. And then the question naturally arises, what would it take to run Linux on them? This was the answer that Linaro set out to answer in a project funded by ARM and indirectly by Qualcomm. We've received hardware from Qualcomm and Lenovo that we used for this, and the idea was to do a proof of concept to see what would it take to run mainline Linux on these ARM laptops built for Windows, see how far we could get, identify any gaps in what's already upstream, any potential blockers, and so on. And the primary developers have been myself and Björn Andersson, who used to lead the, Linaro Qualcomm landing team, and who's now with Qualcomm, and then the landing team itself. But of course, we're building on work that's been done by Qualcomm and the landing team over the years in upstreaming support for these SoC families. And since this is Linux, we're building on work of many, many other people, of course. So the machine that we've been using and enabling Linux on is the Lenovo ThinkPad X13s. It's based on the 3rd generation Snapdragon compute platform, has a pretty beefy GPU, all the features you expect from a modern laptop, and my favorite thing, it's fanless, it's light, and it's pretty snappy. The boot firmware on these devices is a UEFI implementation from Qualcomm, a customized one with some quirks. So for example, runtime services are not available after boot. So you can't use standard interfaces for accessing things like E5 variables. There's been some prior work, projects between Linaro and ARM to see what we would take to run Linux on Windows and ARM laptops. And one of the outcomes of those earlier projects was that it wasn't feasible to use Qualcomm's non-standard API implementation. So we're describing the hardware in device tree, and the idea is to eventually ship the device tree with the UEFI firmware, but also an outcome of those earlier projects is an EFI loader application, DTB loader application, that can be used to read the device tree blob from the EFI system partition and make sure that it's available for the kernel when booting. And this will eventually allow for generic distro installers. Another quirkiness of these machines is that they come with a hypervisor that's started during boot. So the UEFI firmware and Linux starts in exception level 1, which means that there will be no hardware virtualization on these platforms. Throughout the project, I've been publishing work in progress branches with important fixes and features that are still under development. This was especially important early on in the project when it was just me and Björn working on it, to share things like be able to access the NVMe and display. But also when more people got involved and then we got a community around the laptop, a lot of people have been running these work in progress branches to, well, if they want to run RC kernels, there's no use for everyone sitting there and debugging those regressions when I've already fixed it. The branches also come with a reference kernel configuration, it's a service for distributions, minimal configuration. That's what I'm running on my machine, but it has all the features enabled that you need to run the X13s. And I've been rebasing this more or less weekly on RC kernels, and by staying this close to mainline, I've been able to find and fix several regressions very early on before it hits the distributions and end users. And so far, it's about 70 branches. The latest one is not RC7. I pushed the 6.9 branch yesterday. But yeah, I typically announce these on the Arch64 laptops IRC channel as well, with some changelog of what changed from previous versions. So the feature in mainline that we've been working on, we got the basic stuff upstream for 6.0, keyboard backlight, USB. 6.1 we were able to suspend the system without crashing. 6.2 added support for PCIe. That took a little while because we had to deal with some technical debt in the upstream PHY subsystem. And this was needed to deal with because we had a 4-lane PHY in these machines. It was a new feature. That allowed us to enable the NVMe modem. 6.3 battery and the display, both external and internal display. And by that time, you could run mainline Linux on these machines with just a single patch, and it was the IOMMU patch to work around a quirky feature of the platform because of the hypervisor. 6.4 also added Bluetooth. Alternate touchpad had to do with the fact that we had to rework the logic, the locking in the IRQ core interrupt mapping handling to be able to probe for both touchpads in parallel. Wi-Fi also took a little longer. I'll get back to that in a minute for why. And with 6.5 we had audio merged, GPU, and by then we had a pretty complete system from pure feature standpoint. For distributions, the important E5 variable support was added in 6.7 as well, and I'll say a few more words about that later. On the firmware side, we've been using the Windows firmware for bring up, and then work with Lenovo and Qualcomm to get the rest of the firmware released and get it into Linux firmware. I mentioned Wi-Fi took a while longer, and that had to do with the fact that the board file that comes with the Windows driver is not compatible with the firmware that Linux uses. And that carries things like calibration data, so we really needed that for proper both compliance and speed. And this was one of those things that took a really long time to get released. We needed to figure out what was wrong, find the right persons within Qualcomm to talk to, find someone who cared enough about it, and be able to repackage and sign and eventually push this out to Linux firmware. But by September of last year, we had everything in Linux firmware with 2 exceptions, and that is that we're still waiting on Bluetooth calibration data. So the Bluetooth, we have some connectivity issues. The range is pretty small, short. Similarly, we've been asking for access to the video acceleration firmware, but so far we have come up with nothing. But the workaround here is to use the Windows firmware. So there is a path for developers to be able to use this properly, and then the Bluetooth range is perfect. User space dependencies, pretty slim, small set. You need the recent ALSA UCM for audio. As mentioned, Linux firmware. There's been some updates to the Wi-Fi drivers, the generic Atheros driver. So you want to have be able to use you want to consider using the latest one for the latest fixes there too. The GPU has been supported since Mesa 23.1, and you need modem manager new in 1.20. And all of these Qualcomm SoCs require a user space daemon called a PD mapper running to be able to access the services provided by the remote processors in the system. And that involves things like battery indication, USB orientation detection, and audio. And there's still some work in progress on this machine. For the last year, there's been a lot of work going on the camera side to be able to read out raw sensor data from the sensors. We won't be able to access and use the hardware ISP. So instead, an implementation has been done in libcamera. So you're doing things like debayering in user space. That work's been merged to libcamera. It hasn't come into a final release yet. And most of the bits are in the upstream kernel as well. Some bits missing. I'm expecting this to be enabled for 6.11. DisplayPort audio, not yet enabled. There's some preliminary work out there. Qualcomm has been pushing and having an interest in enabling EDP panel self-refresh. That should enable to squeeze out a little bit more battery time from the device. And 2 things that were merged for 6.10 just recently was the fingerprint reader, dependent on some USB rework. We were depending on an external third party for this. Took a little while longer than expected. And the final bits for USB power and delivery has also been merged. Video acceleration is supported since a year now. We're still waiting on the firmware, so we can't push it upstream. And but it's been working, and it's available in the VIP branch. And then, of course, throughout the projects, we've been running into a lot of bugs and usability issues now that we're dog fooding using these machines ourselves, and we have actual users using these machines for everyday use and various use cases. Performance optimization is also an ongoing effort. There's some thermal work going into 610 as well, and we have known issues that we know that we can push a little bit more out of it, but it's still pretty snappy already. Power consumption can absolutely be better, especially the suspend power consumption. And we're currently at around 15 hours of idle time with the backlight at a fairly high setting and just Wi-Fi connected. As an example, if we enable when panel self-refresh is enabled, you can squeeze out another 2 hours. And for suspend, we are unfortunately not yet hitting the deepest low power state, which means that you get around 30 hours of suspend. It's enough to get you home from work, last overnight, unless the battery is drained. But we really want to make sure that we find those last bits that would allow us to enter the deepest low power state. And some bits that we have identified and that we haven't had time to look at but needs to be done at some point. One obvious issue is active speaker protection. These devices come with speakers that depend on overdriving them, so you need some kind of protection in the DSP, and there is support in the DSP for having active speaker protection. For now, we've just capped the volumes, so the speakers aren't very loud. They're decent, but you should be able to drive them much higher. This also depends on getting access to firmware and things from Qualcomm. We unfortunately still don't know how to access the Bluetooth device address and the Wi-Fi MAC address, so those needs to be set manually for now. This has to do with the fact that the addresses aren't programmed in the controller. Instead, it's read out from some storage that's controlled by the Secure World firmware. And we haven't had access to the interface, and we haven't had time to try to reverse engineer it ourselves. Camera ISP, I mentioned, needs to come from Qualcomm. We can't do anything about that. We're using a soft ISP solution for now. Similarly with virtualization, depends on having an entirely new boot chain. Probably won't happen on this platform. Hibernation is also one of those things, not supported on Qualcomm SoCs generally in mainline. And it depends on working throughout the kernel and all drivers, making sure that all drivers suspend and restore their state. Some minor issues, special keys not working because they're handled by the embedded controller. We haven't had access to the interface. Thermal throttling we do. There's GPU thermal throttling. There's a bug in the upstream right now, but we are throttling the CPU and GPU soon. But that can be extended with support for taking the DSP and charger and radio into account. And finally, there's a trusted platform module for storing keys, etc. in the machine. We don't know how to access it. We haven't had time to try to reverse engineer that either. So, some lessons learned. Well, one of the obvious ones is that we've only had one full-time developer, me, on this project. And even if and the kernel is a fast-moving target. Regressions happen, that's normal. People upstream support for new features, and they inadvertently break something that affects us. So you need to, even though in theory, if you have your stuff upstream, it's just continuous work, someone else's problems, you need to pay attention to what's going on. You need to report things early on. You need to narrow it down enough for someone to care about it. And that can take a lot of time, depending on what happens. Critical bugs, obviously prioritized. If we have actual users on these machines, if they plug out their, disconnect their display and the thing crashes, we need to fix that if it's not a really esoteric use case. And then, of course, all the features that we want to implement, including things like optimizing power management things at the end. Firmware has been a background task, talking to Lenovo, talking to Qualcomm, reminding people, but also reminding upstream about bugs that needs to be fixed and so on, and supporting the community, making sure that their reports get triaged, either fix it yourself or make sure to report it to upstream. So it's a lot of work. And just to mention one example there, we had some display regressions in 6.9 in the upstream Qualcomm display driver. It turned out to be 3 different regressions. It manifested itself that like random resets every now and then. It seemed to coincide with the display subsystem initializing, but that's not enough to go poke finger at upstream and say, hey, you broke something, because it seems like it's related to the display. And that brings in the next point as well with the hypervisor resets. So things like unclocked accesses that generate system errors are trapped by the hypervisor, which just resets the machine. So you don't get a stack trace or anything, which could have been the smoking gun otherwise to upstream. And the regressions were also of they were race conditions. So it took like 40 to 80 reboots before they triggered. So it's a bit of a pain to track down. But in the end, this led to more eyes on this driver and the hot plug implementation, and we realized that it's completely broken and needs to be reworked. So something could come out of it, but I didn't get to spend the time on the stuff that I wanted to do during the 6.9 cycle because of this. I've already touched on the lack of documentation. We've had to spend time on reverse engineering. We had help from the community with reverse engineering the 5-variable interface. But things like that could have gone much smoother if we had more buy-in from Qualcomm. And as I mentioned, we still don't know how to access the Bluetooth and Wi-Fi MAC address. Firmware access, another pain point. Wi-Fi calibration took a year. I mentioned that before, and we still haven't access to the Bluetooth calibration data. Not sure exactly who to talk to. We've tried through Lenovo, through Qualcomm. I've even talked directly to the engineers. But still no luck. And we're just waiting. It's like 1,500 bytes with a difference in, tens of bytes from what's in Linux firmware. So it's really just, we haven't found the right person to talk to. Video acceleration I mentioned, still missing. Firmware updates. There has been, so Lenovo's been pushing updates to Linux firmware, but those firmwares have had updates since, which we haven't been able to get into Linux firmware. And I think those last 2 points are being worked on. I think it's being resolved within Qualcomm, but it's still taking time and we still haven't got it. But another important part of the project, or lesson learned, would be the importance of the community. So those prior projects resulted in setting up an IRC channel on OFTC called RH64 Laptops, where a lot of people interested in these machines and running Linux on ARM hardware are gathering. And this has been really useful, not least for help with testing. So we have a lot of users using a wide range of distros, different use cases, different peripherals. And yeah, on top of us, dogfooding and using these ourselves. But the important part is that these are everyday users. They use their machines at work, they run it daily. They tend to catch those corner cases that you don't necessarily hit if you're just enabling features, ticking boxes on a development platform that you don't even take it with you to the sofa or to a cafe or something. The community has also been helpful in supporting new users, propagating information, workarounds, and so on, so we don't have to keep repeating ourselves. And we've also had some really important direct contributions from the community, and I really want to highlight Maximilian Lutz's work on reverse engineering the interface for accessing the 5-variables. Did an amazing job there, and we also had help from Rob Clark, the free Drino maintainer, for enabling A690 Mesa. And Steve Klimachevsky has been helping out bringing up Bluetooth, and he's also very active on IRC, helping new users and guiding people to the right people. And finally, I also want to highlight Nikita Travkin's work. He's actually been able to get Linux to boot in exception level 2 and thereby enable virtualization. Unfortunately, it's probably not something that's ever going to go upstream because of you run into a lot of problems with unresolved issues, like how do you start remote processors, which currently involves the hypervisor. But it could have a use case, for example, for the things that I mentioned before. If you have these bugs that you're debugging and all of a sudden you just get the random resets, perhaps booting in EL2 will give you a stack trace. And finally, I want to say something about distro support. A goal of this project is to make sure that everything is upstream, and that is something that we have achieved. So essentially, any distro should work on these machines, as long as they have recent enough firmware, and of course, the kernel needs to be configured properly. But if you build your own kernel, you can run anything. I run Arch on mine. There is no official Arch support, but it just works. What distro can provide, however, is an installer, installation guide to make it easier for newcomers to set things up. We've been, manually installing, creating our own USB installation media and so on. It's not something that you want to force on regular users. Two examples here are Fedora and Debian. I haven't tried their instructions or their installers myself, but I understand that they're pretty straightforward and working by now. And also as a service for the distributions and users alike, I've been maintaining a wiki in the repository where I publish those work in progress branches with updated status, known issues, workarounds, etc. So if you run into something, you might check in there for if it's a known issue and if it's a workaround. There is a workaround already. But to sum up a little bit, the state of Linux support for the ThinkPad X13s is quite good. We have several developers using it as their primary laptop. And this is something that has been achieved with very limited resources. Importantly, the work that has been done will benefit future platforms directly. It's been changes to core kernel code, Qualcomm code, absolutely. And the remaining issue are generic Qualcomm issues to the largest extent. So this is stuff that needs to be addressed for any future platform in any case. And given the fact that we have this largest user base running mainline Linux on an Arch64 laptop that already help out with quality assurance, not least in terms of regression testing and so on, I definitely think that the X13s should remain a priority platform. It's probably the best supported ARM laptop that we have. And it's definitely the best supported one in this category, which is as powerful as this one is. I'm pointing at the wrong laptop, but you get the point. Yep. So, thank you. Any questions? I've been told we should ask questions in the microphones.
Yeah, okay. So, I've also been using actually two of them for the last almost 2 years, a Linux one and a Windows one. But I have two questions. One more fundamental. Why does it sound like a struggle to get attention from Qualcomm?
Well, if it wasn't clear, perhaps I could have highlighted it more. So we didn't have any buy-in from Qualcomm on this project. It's a big corporation. There are a lot of different divisions there, but there wasn't a commercial project to enable Linux on these machines. It's been individual developers like Björn, who's with Qualcomm, who cares about this. We have the Wi-Fi maintainer in there, who's been helping out a little bit with that part of it. But otherwise, it's networking, finding the right people.
Yeah. It just because if you look at like M1, M2, M3, and the whole now the Elite CPU coming out, and this urgency to beat the numbers, but then to bring the support. I mean, my understanding is if you want to enable Windows on ARM as much as you want to have Linux, it's solve it first in the Linux world, go all in on that, because you can see a lot of upstreaming on M2 and M3s, because there's just simply more eyeballs on that code. And like you said, dogfooding is the best way to iron out those bugs. I mean, the sense of urgency on the marketing side doesn't seem to correlate very well on the engineering side.
No, as I said, it's been a skunkworks project, if you want. We're doing this unofficially, enabling Linux on something which isn't supposed to run Linux. But we've still achieved something. I mean, compared to the Apple hardware, everything is upstream here. You can just run any distro on it.
Yeah.
It's in the kernel.
Okay, thanks.
Ras. So you spoke about speaker protection. Check safety speaker from Asahi.
Yeah, I'm aware of it. That's a user-space implementation. We don't need to use that because there is support in the DSP for doing these things, which would be more efficient and safer than relying on the interaction with user space. So there is still hope that we'll get it, but we'll have to cross some of those hurdles, access to firmware and so on. But again, as most of these issues, they apply generally to all Qualcomm platforms. There is interest from Qualcomm, at least from the Linaro side of things, on getting this fixed.
And I understand you about keeping speakers. I remember smell of melting plastic when I smoked my Chromebooks 12 years ago.
Yeah, you spoke a little bit about Qualcomm's custom ACPI implementation. Could you explain more about what that blocker was? Why it was a problem there?
So a lot of the things depends on having it's the PEPs, plugin extension thingy, and so a lot of the power management bits are implemented in binary code running in Windows. So we can't reuse that. We would need to implement those things anyway. So basically, it's the PEP, and there are some other bits in there which make it. It's an incomplete ACPI description. It's not that we can just take it and run on Linux.
It's ACPI imitation, not implementation.
Yeah. Can you pass the mic?
So the Linux code, right? It was all completely from upstream that you used to bring up on this Snapdragon.
Yes, it's all upstream. So we've been, I'm running 6.9 on mine right now. You've been able to run mainline Linux in 6.4 without any patches on top.
And just a follow-on question for somebody that has asked. So who with Qualcomm were you working with? As in, when you said you got some amount of support.
So Björn has joined Qualcomm. Björn, who used to be at Linaro when we started the project. So he's been a tremendous help in accessing both people and documentation and things in there. But that's the only one on Qualcomm, except for the Wi-Fi maintainer, I guess, and then direct interaction with engineers on the mailing list and so on.
Thank you.
That's yep. Any further questions? All right. Thanks again.